And our final proper talk, as opposed to the lightning talks next, is Sami from Nokia, who's going to tell us how to drive human error to zero. I look forward to a great week coming up. We all take advantage of it.
Proper talk is probably a big promise, but okay, let's see where we get. Yeah, I mean that's the idea. So let's talk about the automation, where we are with the automation, and what are the stumbling blocks with the automation that we want to do. Because if we look at our industry, the full automation has been like a wet dream now for 10 years, 15 years, whatever years, right? We have gone through the stages. We are going to the model-driven interfaces or model-driven operating systems. We are working on the intent-based, network management tools and everything, and so on. And the vendors have been putting a lot of money in there. I could imagine that you guys have been putting a lot of money in there, and so on. So where are we now after that 15 years of that wet dream? I saw a study, and the networks are most stable during the holidays. So that only tells you guys that it's not really happening in there. And I also saw a study which basically said that even having some autonomous operations in the networks, the percentage that the providers and the network operators they had, it was seriously low. So we're not really there. Despite all the good efforts that we've been doing, all the evolution, all the money that we've been pouring in there, we're not really in there. And one of the reasons is that people don't really understand the automation. The automation is neutral. So if you do it bad, it will actually exaggerate the issues that you have. Okay, if it's good, then it will help you guys to automate. So why are we actually in this situation? After all the effort that we really put in place. And part of the blame is actually on the vendors. Us, us Nokia, Cisco's, everybody in the vendor. And one of the things is that, even if we have those fancy intent-based environments and then tools and everything, those intents, they are actually very opinionated. If you look at from the helicopter view, the layer 2 service is a layer 2 service, and layer 3 service is a layer 3 service. But it's in the end of the day, very often it's actually the vendor's view of what that layer 2 service should look like, what that layer 3 service should look like, and then so on. The other issue is that there very often is that there is no return path. So yes, you can deploy your intent into the environment, but what if something changes? Maybe that intent is not exactly what you want, and then you go with the CLI and you fine-tune it a little bit. Or something else happens. One of the switches, they actually, they go to old configuration or whatever happens, in there. And if your tooling doesn't actually track what's happening in those nodes themselves in the network itself, then you don't really have like a single source of truth. And let's say that if your tooling believes that the network is in certain state, and it's actually in the other state, and then you start deploying on top of that one, you will actually, just exaggerate the issue. Well, okay, but that's what we vendors do. That's the issue. That we have done. We build the environments with the opinionated way. Now, maybe the bigger issue is that it's actually about the mindset, and what I mean with the mindset is that we are actually trying to automate the manual operations. And the target has been that we want speed. So we want to do it. Accelerate. And like we discussed, maybe your tooling is not in the sync, and then so on. And then you start causing issues with that automation. So it's actually about the reliability. And if the reliability is the issue, then people will not believe it. And then if people doesn't believe it, then people will not use it. So that's the issue. So how do we actually start really going into that path of the full automation? It's basically, get to that wet dream. That we will use the automation to drive the human error to zero, and everything will be fantastic. It's about reliability. So we need to get things reliable so that people can trust them and start using them. In full. So if it's about the reliability, then why don't we actually take an example from other industries where the reliability has really been implemented. And the airline industries, even with those very unfortunate recent news that we had last week, but in general, airline industries is very reliable. It's probably the safest way to travel. And how do they actually deploy the reliability? They have all those checklists, pre-checklists before the flight. They go through everything every function, everything in that plane before they even start preparing for the takeoff. Everything is redundant. You have two pilots, you have all the control systems, everything. It's doubled. Even the wiring is doubled, and everything. So they implement a lot of redundancy in there, and then they have the visibility. They use the telemetry. They have all those things measuring all the functions in that plane and everything. And even before that one, all those pilots, they go through the flight simulators. They simulate all the potential issues and events that might happen during that flight. It's about the checklists, it's the pre-checklists, it's the post-checklists, it's training, and it's simulations that you require. Now let's come a little bit further to our industry. Where do we see the automation? It's basically in the IT space. So here we have the CI/CDs, we have the DevOps, everything. So this is the area where we actually see some level of automation, not in the network automation, but automation anyways in a business branch that is very close to what we guys do. And there we have Kubernetes. Kubernetes, it's designed to manage those containers. But that infrastructure is very flexible. So the Kubernetes gives you the possibility to integrate with all neighboring systems, the CI/CD, network as a code, whatever have you in there. It's already managing on top of the containers, the bare metals, the storages, what have you. So and it's like widely accepted. Like 5-6 million users every day. So this is basically the model where we want to go when we start to go towards the automation. To have the environment that is flexible, that is transactional, and designed for managing a huge number of objects in the network. So about those objects, the pod is a pod is a pod. If you look at the Kubernetes or containers, the pod looks very much the same, independent of the distro that you have and so on. It's only like a minor tweaking to go between the different distros if you want to deploy the containers and those pods. So if we move to the networking, interface. Interface is actually very similar looking, be that RS or Linux, SROS, be that Cisco, be that Arista or what have you, or BGP peer. It's very similar. So actually, if we compare it to what the Kubernetes is doing, we're not actually doing that much different compared to those guys. So basically, what we can take from the Kubernetes is that we start to model those what we call primitives. That we have those simple primitives, be that interface, be that BGP peer, some policy configuration, whatever have you. And then we just built a logic which is mapping them together, and that actually gives you the configuration. Now, building those primitives, like I said, it's not actually that different between the different vendors that we have. So of course, it assumes that we can use the model-driven operating systems. Some of those are more better organized than the others, but in general, it's still very much the same thing. And then mapping those primitives, that actually gives us the configuration that we can deploy. Now, in my first slide, I said that vendors are actually part of the blame because everything is opinionated. So even if you go with the Kubernetes model and so on, then we do the abstraction and kind of declarative abstraction, and then we deploy that one. What makes it different from what we have today? It's still like a black box that is doing something once you give the input for those intents. The answer is openness. So the idea is that we have an app store where we have all those components that are doing it. So I will have like an app for the interface. I will have the app for the layer 2 service. I will have for EVPN, BGP, what have you. And then for the interface, I can actually have like a multiple of those. It's open. Everything is in a Git. You can download them and put there. And if we don't have an app for a function that you guys want, let's say it can be like a router interface. It can be like some CRM integration and what have you. It's open. You can ask us to write it. You can write it by yourself. And so on, and then put them into the Git. So everything is in the Git, everything is lifecycle managed, and so on. So it actually, gives you like a tooling to scale wherever you want to actually take that environment, which is very much the same what people do in the Kubernetes world today. Right. Now, IDA app, what it is actually, it's of course the configuration, but it absolutely is also the state, and maybe some other operations. But so that you have the real-time visibility on what's happening under that application, under that function in your environment. Right. So what does that actually mean in practice when we start to deploying it? Okay. Now we have our apps in place. We have, tooling to manage the equipment that we have in the network. So what happens when I want to provision something, when I want to do some action in my environment? So I go to the model-driven interface. I define my intent, what I want to deploy, and then we a little bit follow that airline model. We will do the pre-checks. We do all the syntax checks. We look at that the ranges, they make sense, and everything. After that one, once we have done the pre-checks, the dry runs, and everything, we actually deploy it in a digital twin. And only once we have deployed it into the digital twin, it's deployed, then we do the post-checks. Does the outcome actually look like exactly what we want it to be? And only if everything looks like it should be, then we actually commit, deploy that one into the network itself. And regarding those post checks and everything, this is something that we have to do continuously. Because like I said, if something happens in my environment a week from now, I want that my environment knows that what is my new state of my environment before it starts deploying. Now, the digital twin, I'm sure everybody understands the value of the digital twin. It's digital, so it probably helps you guys with your capex costs. It can be part of the management tooling itself. It can be, sitting somewhere in the cloud, say, like a container lab or some other environment. But the idea is that it is exactly the same digital, twin, because you do all the checking. In the twin. Now, you can do like a big changes in your network. We have a demo where we actually change our system IP addresses from IPv4 to IPv6. I mean, if it's a little bit bigger environment, you can imagine, how big thing that one is. It's like thousands of lines of configuration and lots of things happening. So what we do is we use the transactional side of the environment and we split it into the smaller configurations. So shut down the services, change the IP address and everything. And we split it into the smaller steps, but we maintain that the transactional model. So we want to make sure that, well, of course, after all those pre-checks and the tests in the digital twin, we go to the environment, we deploy it, and if a single one of those tasks fail, we will actually roll back to what we wanted. So because probably the worst thing that can happen is that you have the partial deployment, and that can actually create a lot of issues for you guys going in the forward. So the idea is that yes, we split it into parts, we deploy it, we track every change, we track. We have the real-time telemetry, we see where we are. In the functions. And then only after complete successful deployment, then we kind of, go into the post-check mode of that change. And it's with the version control. So the database is actually a Git, and after every commit, we make a new kind of a version available in a Git, which means that we can revert always to some previous version of the full environment if needed. I talked about those post checks and the sanity checks that is our view of the environment same as it is the latest in the Git. Let's say that we have one CLI hero who has been going there doing some changes and we're not actually in sync. Now, those post checks, they need to be run like a real time, and with the decent telemetry infrastructure. We always see that there are changes in the environment. We can track then, what the network looks like versus our intents, and if there is a change, it actually offers you the possibility that, okay, we can revert back to the old golden config, or maybe those changes that have been made, they are actually something that you guys want to deploy. You want to make those. And then you can declare that this is my new latest golden configuration. And then going forward from that one, that will be like the step that, if you need to roll back, you go into that stage again. So basically, this is what we do with our event-driven automation. The whole idea is that we will make it predictable. We will make it that it's always on. It's always aware. What is the state of your environment before we make any changes in there, and through the openness and everything like that one. We try to make it very consumable. And the outcome should be that it is reliable. It is something that you can trust because it's tracking the environment all the time, so that you can actually trust it. You can let it work. As it is. It should also as on top of that one simplify your life cycle management and so on. And then with that app model, if something new, some new ideas come, some new vendors want to be adapted or anything, then you can write that app or which way ever. And everything is running on top of the Kubernetes. So the platform that you guys probably know really well and you trust. Thank you.
Thank you.
And if you have really clever questions, ask them to William. Where's William? There.
And only if they're really, really short. Will you be at Sauna?
Yes. Yes, I will. Yes.
Great. So plenty of time for questions.
Yes.
Thank you.
All right. Thanks, guys.